Right, I'll make it 1 minute past. So if we're ready to start, Robbie.
Yes, go ahead, David.
So hello everybody. We'll say hello rather than good morning, good afternoon, wherever you are in the world. Welcome to our first webinar looking at automated testing in this particular session. This is the first of 3 webinars that we're conducting with Reltus software, looking at the ProcedureCapture tool. For each session we'll be doing just a little bit of background on some of the industry-specific issues in life sciences, and then looking at how ProcedureCapture provides the functionality to address those issues. So I'm David Stokes with Compatibility Consulting. I'll give you a little bit of background at the moment, and doing the bulk of the work today, I'm pleased to say, is Robbie McConnell from Reltus Software. He'll be actually walking us through the demonstration today. So during today's session, what we're going to do is just provide some background on automated testing tools and regulatory compliance in life sciences, provide an overview of the ProcedureCapture tool. That'll be an overview of all the functions in the system. And then specifically today, in the first of the 3 webcasts, we're going to be looking at the key features of the testing plus automated test script recording and execution. There's a lot more to ProcedureCapture than that, which is why we're running the 3 webcasts. We'll be looking at some questions at the end of the session, so if you'd like to enter some questions, if you have any, in the little dialog box, we'll address those at the end. So we'll be collating those and covering those at the end. So as I said, my name's David Stokes. I've been in the life sciences industry and specifically in computer systems validation and information systems compliance for 30 years. I started getting into software testing as a process control engineer, and we realized pretty quickly that if we didn't have some structured and documented testing, primary pharmaceutical plants can have a tendency to explode, which isn't good for anybody. So I was very interested back in those days on how we defined and obviously documented our tests. That led to an interest through GAMP, which I'm sure many of you have heard of. I wrote a supplier guide for testing before suppliers were actually allowed to join ISP GAMP. Wrote a book on the topic, and then that led to work with the special interest group within GAMP on testing of GXP systems. Chaired the team who wrote the first version of that guide, and then as we refreshed that guide a few years ago, we were asked to look specifically at automated testing, the computer-based test tools. GAMP in Americas and in the German-speaking GAMP DACH region did a lot of work, and I was responsible for working for those 2 teams to pull that content together, which forms a lot of the background to current regulatory guidance on computer-based testing. So I'm still quite heavily involved with ISP and GAMP, and still very interested in testing as a topic. But again, I started working with testing a long time ago, before we had computer-based testing on paper, and if I'm honest, probably most of the testing I get involved with these days still uses paper. That can be pretty slow and inefficient, and there's a number of historic reasons for that. Of course, originally in life sciences, the approach for testing software was derived from the regulations around testing pharmaceutical or medical devices product, which is generally of much higher risk. But in some cases, we saw an overreaction to what was considered poor testing practices and poor test documentation. Even now in the general software industry, we see a lot of different approaches to testing in terms of the quality and control of the documentation. A lot of organisations do a good job testing software, but not necessarily in controlling that, defining it and documenting it. So it's very important to cover that off. We also saw an overreaction to a couple of things. Certainly I've worked on plenty of projects where people have been caught cheating in testing. They falsified paper documentation, which has been a problem, and that led the industry to develop a very, very rigorous approach. So typically we used to use test witnesses. We used to have somebody look over the shoulder of somebody executing a test to make sure that they did it properly. Now that was more stringent than when people test pharmaceutical product in the laboratory. So if we trust our testers, if we train them properly, that shouldn't be necessary. We also saw, certainly 16, 17 years ago, an over-interpretation of the scope of Part 11, which made it very time-consuming and onerous to implement computer-based software testing tools back in those days. So as an industry, we still tend to rely on paper a lot, but as we've said, that can be slow and efficient. It can be relatively easy to falsify test documentation. The easiest way to do that, of course, is just to fill in the results without actually executing the test, and I've worked on projects where that has been done. Obviously we have to address those issues when they arise, but paper still has compliance issues. Every project I work on, if we're using paper-based testing, somebody will lose a sheet of the test. They will lose a signature sheet, and it takes time and effort to explain that, and occasionally it means we have to repeat testing purely because of issues with paper. And I think the other issue we have with paper is when we're testing across multiple sites. Actually managing the paper, sending faxes backwards and forwards and scans can be quite a lot of overhead, where quite frankly we don't need that these days. So a few definitions before we move on. So I've been using the phrase computer-based testing. Really that is testing which is conducted, it's executed manually by people, but rather than using paper to execute the tests and record the results, we're using a computerized tool. So we manage the test case or the test script electronically, we execute and record the results electronically, but it's still driven manually. Automated testing is essentially where, as the name suggests, we automate that process. So we use some sort of program to drive the testing and record the results. Saves manual effort, and obviously one of the big paybacks there when you automate the right tests is that you can do more testing, and certainly if you're developing a product or rolling out a system where you have to test it multiple times, you can get good payback there by automating a lot of that testing. But as we'll hear later, not every test is a good candidate for automated testing. Over the years, we've had various discussions about whether test records are part of or within the scope of 21 CFR Part 11. Generally, they're not considered to be these days. There are some cases where that may be the case, and the GAMP guide testing of GXP systems does explain that. What is key, however, is that we have data integrity of our test records, and that our computer-based testing tools enforce our testing processes. That requirement and the requirement to assess our computer-based test tools for fitness for purpose comes out of Udrelex GMP guidelines, specifically Annex 11 on computerized systems. So again, we need to make sure that any computer-based tools are appropriately enforcing our our testing processes and our test SOPs, and make sure that we have security both around the test case, the test script, and the test records. So I've been involved in computer-based testing in life sciences now, I guess, for almost 20 years, and some of the traditional systems we were using then, which have been updated, still on the market, have a number of traditional drawbacks. A lot of those tools lack the necessary data integrity and security out of the box. And although it is possible with a lot of those systems to configure them so that you do have appropriate workflow, you do have appropriate security, it can take literally weeks, or sometimes I've seen customization around that. It can take months to set those tools up, which is an overhead we don't want these days. Very often those tools still require us to manually develop our traditional step-by-step test scripts and our test instructions. And while a good tester can write those instructions well, very often if we're getting users to develop their own test cases, it's not something they're always particularly good at. Users aren't particularly good at developing structured challenge tests or negative case testing. They're much better at playing with the system and trying to break it. And as we'll see in a later webcast, that's also something now that ProcedureCapture supports very well. And if you're automating, a lot of traditional test tools require specific knowledge of programming languages to be able to develop the scripts that drive the automated testing. That takes time to learn, that's quite an investment. A lot of organisations bring those specialist resources in from outside, and typically there's a lead time to get hold of those people, and that level of special expertise, of course, doesn't come cheap. So for all those reasons, some of the traditional systems that have been developed for broader use outside life sciences aren't always the best solution. So myself and a number of other people in the industry, individuals and regulated companies, have been working with Raltus over a good number of years now to help develop a tool which specifically takes on board the requirements of testing in the life sciences industry. And I should point out at this stage that I've got absolutely no commercial relationship with Robbie and the team. The time that I've spent with them and that others have spent with them developing ProcedureCapture to be a better tool for testing in life sciences has been done because we believe in what the team are doing. They are focusing specifically on our industry, which is very important. So as we'll see starting in today's demo, ProcedureCapture is specifically designed to meet the needs of our industry in life sciences. It's designed to be easy to use, both for manual and automated testing, provides very good documentation, so you don't have to spend a lot of time doing that. The system handles that. It's been extended comprehensively beyond just a testing tool, so it will also manage your requirements and traceability of your test cases. It now has built-in support for risk assessment and risk-based testing, and more recently there's been some good support for agile software development life cycles and the sort of development testing, usability testing that users are very good at, and where that unstructured testing captures extra value. So a lot of advantages. So you've probably heard enough of me speak now. I'm going to hand over to Robbie. He's going to tell us a little bit more about the software. If there's any questions, I might pop back later. But at this stage, I'm going to try and hand over control to you, Robbie.
Thank you very much, David, for that intro and your points. If I could just take you through the sort of key points of the tool, basically, and David has touched on some of them there, but really to say that it's, we have a single license for everything, so you're not going to different tool sets to get different pieces of it. And as David said, we go through agile and waterfall requirements, risk assessment, both session-based and structured testing, review and approve, electronic signatures, defect management, traceability and user guides, and obviously the bit that I'm going to focus on today, which is sort of the execution of the test scripts in a manual or an automated fashion. A couple of things to point out. It works across all application browsers and platforms, and we have built it specifically for subject matter experts. So if you can use Word or Excel, you can use all the functionality, so there's no such expert view. And just to give you a little bit of background on us, we've been involved in writing testing tools for about 30 years now, and we've written a couple of pretty well-known ones over the time that we've been doing it. So if I could just maybe elaborate a little bit. There's a sort of a little snapshot of some of our customers, mostly as when they're in life sciences. We do still have some traditional, I use it from a development perspective, but in the last sort of couple of years, most of our customers have come from the life sciences industry. So just to give you a sort of overview of what we have, so we basically manage the requirements, do the risk assessment, capture test scripts, review and approve them, and then, as David said, we still allow for people to do paper documentation. I'm not going to go into that today at all, but people still want it, so we allow them to basically output it if they want in a document and wet ink sign it. But increasingly, this is the route that most people are going in terms of paperless execution, either manually executing the test script or using our automation tool within the test script. Either way, you get your audit trail, your validation reports. We also then have your sort of defect tracking if you have any issues, so you can manage your defect tracking. generate your traceability matrices, and also from your test scripts you can produce end user training materials. It's worth also pointing out that we will cover this in the next session, but the risk-based approach propagates throughout all of that. So your test scripts take the risk from the requirements, and the defects, if there is any, take the risk from the test scripts. So just touching briefly on each of those before I sort of move into actually demoing the software. So requirements themselves, we have basically the ability to have your user functional design requirements as effectively separate grids, and you can manage those grids, see what's going on, sort them. It's easy to see what's going on in terms of doing it, and you can link the requirement, if you like, between each requirement hierarchy. So your user functional requirements, you can see what the hierarchy is, control that. And you can then also, select and link those requirements directly to test scripts. The other thing that's very useful is to be able to see the traceability in real time between the requirements and the test scripts, and see in your project where you are and what you have to do. So that's your requirements. As I said, the risk assessment, we're doing a whole webinar on this, but I'll briefly touch on it, that we allow various risk assessment models, both for system and requirements, and you can version the risk so you can see what's happened before and after it. And as I said earlier, once you assess it, then that will propagate throughout your tests and defects. So on to sort of capturing the test scripts, and when I'm talking about test scripts now, I'm talking about functional tests that show you that usually, and we follow pretty much the GXP guide in this in terms of having supporting steps, and then you would have a proving step that proves it. And while we can do both, if you like, description test scripts as well, what we see most people doing is using our visual storyboard, and the reason they do that is because they're able to see what is going on with the test script easily, and I'll sort of compare and contrast those a little later on so that you can see what I'm talking about. But basically what it means is that, when people are looking at it, they don't have interpretation or ambiguity issues. And it's amazing when you see, somebody who creates a test script, they write down the instructions, and then somebody trying to follow it and relying on words, and how often they get it wrong, or they don't understand what the important steps are or what the test objective is. So that's kind of your capturing the test scripts. The technology is non-intrusive, works end to end, and as I said, if it's if you can see it on the screen, we'll work basically. There then is the ability to review and approve it and electronically sign that. And again, when somebody who's reviewing it, they're not the person who's created it, and the ability to be easy to understand. Is it the right scope and rigor? Is it the right type of test script? Is a positive test, a boundary test, and based on my risk, what does my SOP say in terms of what I need to do? So being able to understand it easily means that people can then say, yes, this is the right scope and rigor, approve the test script, sign it, and it will lock the test script. So this is actually going to be the test script that the testers will execute, and it can't be changed as such. So that means that they don't go to step 5 and start there and do the little bit in the middle. They actually follow what the test has to do, because quite often things can break because of a sequence as opposed to one screen. So that's your review and approval of test scripts. In the execution, I'm going to look at doing a couple of things. So I'm going to do I'm going to do manual execution and automated execution. And for today's session, I'm really going to focus on structured testing. And what I mean by structured testing is a scripted approach where the tester has steps that they're going to follow, as opposed to a session-based, which is sort of free format, which we'll show in the last webinar session. So it's structured testing, and they can execute it either in a manual or an automated fashion. Just to briefly touch on that, there are things that do not suit automation, and there are things that really should stay manual. So, part of, nothing to do with tool, but part of, I suppose, testing best methodology is deciding which ones to automate and which ones to leave manually. If you're automating it, as I'll show you, you usually have to do a little bit of tweaking, and you have to know where you are in terms of starting it. So I'll get on to that when we do that. And then, as I said, risk, we have a defect management and tracking facility as well, which allows you to basically go through and track your defects. So that's your execution, and when it comes out, you can see when I do this that you have documented evidence that when you look at it, there's no, I suppose it shows exactly what has happened, and therefore you can see what the execution happened and why they were able to pass or fail it. And that happens, and we also output then obviously your traceability matrices, audit trail, user guides, and all that documentation comes directly from, can be customized to come from your own templates. So what am I going to do here? I'm going to take you through sort of an overview of all the different pieces, and then I'm going to focus in on this piece here, which is really your, I'm going to create a test script, but I'm going to focus in on the execution piece, and in particular sort of the automated piece and what you need to do and how it works and what the outputs are. So let us go to the tool itself. So what I'm going to do is give you sort of a brief feel for all the different parts of it, and then I'm going to go back into the test and create a test, and I'm going to execute it. So really the first thing is your requirements view, and this gives you sort of an overview of what's going on, and at a glance gives you the important information that you have. You can do it by time frames, and then you can, and this is for requirements, you can go into the requirements and you can drill down by different elements, and I can go and see it by, failed, and of those failed, how many do I have as high priority. So it gives you a way of easily seeing information that's important, and I can do that both for sort of the requirements, the test scripts, so I can go down and see, by execution, what's passed, what's failed, of my failed, priority-wise, what I've got 63 here, so things aren't looking great. So that's your execution status, and I can drill that down, and the same for defects as well, so you can see what's going on in terms of your various pieces, in terms of your important information. And I can customize this if I want as well. So that's your sort of overview, and where all that information comes from really is the first bit would be your requirements. And I have sort of 3 associated grids that would be user requirement, functional requirement, and design specification. And within that, I would have all the details of, the requirement, its children as such in terms of the functional requirement, and I would also have then obviously all the properties of that requirement in terms of, what system it links to from a risk perspective, and all the various other things in terms of, its children and what has happened to that requirement as well. So that, and also what version it's on. We keep all the versions of the requirements so that you can see who's done what, who's changed it, and how it links together. And similarly, if I just, click down on that, I can then see its children as such and what the properties of its children are. I can also, use this to, if you like, drill down on various pieces in terms of, let's take all the ones that have, GXP impact. And then I might say, okay, let's see, from an approved status and a priority status, what's going on. So I could group them like that and then say, okay, show me my approved ones. And then I might, by risk priority as well, so that I can see for my approved ones, what is happening in terms of those requirements and what I need to do in terms of the requirements. And you can just then highlight the requirements, see its children, and it gives you a way of managing and controlling your requirements. And then I can also see the link between the requirements here, so I can see, the parent, the children, and to the design specification. And managing this is, in Excel sheets or whatever is quite difficult. And when you look at where the errors come from, they can you can trace them back quite often to it's the wrong requirement, or it hasn't been covered, or that doesn't link to the right child, and an Excel sheet hasn't updated, or a macro hasn't worked, or somebody's left. So that's your hierarchy of your URSs. You also have the traceability in real time. So this is your traceability between. So if I go, okay, let's go and get again, we'll get the URSs, and I can see for each of the URSs, I can see what are the test scripts that relate to that requirement. So I can see what has happened in terms of the test scripts themselves. I can see what's the scope of the test script, what type of test script it is, and I can also see the type of the test script, and that's very useful to see what is going on in terms of my overall. So this is obviously the execution status, the roll up of all the tests underneath it, and I can do things like so let's say I've got all my requirements there, and I want to see have I missed any. So I could go here and go, okay, here's all the requirements that I have that don't have any test scripts. So I haven't got around to such testing these, and I might then say, okay, well, show me, by risk priority. So my SOP says that I need to have tested these, and I obviously have no, I need to make sure that those are tested against the overall, and it may be that the children are tested and linked to it as well. So that's your sort of requirements overview. In risk, then you have both system risk in terms of setting up different systems, and you basically can look at what the calculated system impact is, and you can also then look at it from a requirement perspective, and you can have your various different risk assessments on the requirements, and that's by system as well. So it depends on which risk model you're using. So if here's a simple one here, which is only high, low, medium, and here's a more complicated one here, which is detectability and low, high, medium values as well, and the assessment of it as well. So we'll touch on that a little bit later on or the next webinar in terms of how you do that and create that risk priority and how that follows across your test scripts. I'll leave the test scripts for a little minute because I'm going to come back and focus on them to show you how to create them and how to run them. But you also have things here like your documentation in terms of your traceability matrices. So I can create, I have the real-time view of it, but I can also create the documents that say, here's my user requirements, here's the test scripts that satisfy them, and here's the relationship between them, and you can automatically get that traceability pretty much at the click of the button, and you can decide what's in here as well. So that's your traceability. The defects that you create, we have a full sort of defects management and tracking module, and that allows you to track each of the defects in terms of who's doing what with it, who's it assigned to, all that type of thing, the history of it and what has happened to it, and also directly link it to the test scripts that have found it, and that allows, and even the execution here of the run that has found it, and that's very useful because you can show the actual developers what were the set of circumstances that actually caused the defect. I mean, quite often the problem is replicating the steps that repeatedly cause the error, and to have that sort of, this is what I ran, these are the steps I did, and this is what happened. So that's an overview of that, and then for your reports, this is where you have your full list of documented evidence of what has happened in terms of all your test results, and I'll create some of these and drill down into the details in a minute. So that's sort of an overview of what you have. If I could then go down into the tests themselves, so we have various different types of tests, and the ones I'm going to, as I said, I'm going to focus on today really are the automated tests and the structured tests. So these would be little flags here. So this structured test, and what I mean by a structured test is something that has, usually you would see your actual, your expected and your actual would be the two values. So you have the tester as a set of steps they follow A session-based is much more, we create a video of what they're actually doing during the testing, but we'll touch on that on the third webinar. So that is your structured testing. And these, what I'm going to do is I'm going to create them. The first one I'm going to create is really with a visual storyboard, and then I'll open one that's not a visual storyboard. Do you see the difference between the two? So let us create a test script. Okay. So what I'm going to do is I'm going to create a test script for the null account. And I'm going to make it a structured test, and I'm going to give it a test number. I'm going to give it a unique test number. Let's say it was a PQ test. And I'm going to pick a URS from my requirements. So I'm going to go and pick a user requirement here that this relates to. So this is the actual grid of your user requirements. So it's easy to pick it. And as you can see, we start to pick up the risk here in terms of doing it. For this one, I'm going to have it this, and this is simply how you replay the visual the visual storyboard of the test script. And I'm going to make this a positive test. So that's how you would create the properties of it as such. So I'm going to create the properties here, and this is my test script. So I'm going to open this test script, and then I'm going to start capturing it. And this is how you capture a test script from scratch. So I simply say start capture, and then I follow it around what I'm doing in terms of the test script. So for this test script, I'm going to open Siebel. Siebel is Oracle CRM, but it doesn't really matter what system's on the screen for us. I'm going to go to the accounts screen. I'll go to all accounts, and these really are what you would be terming supporting steps. And let's say I want to check that these icons are down for all accounts. I would add a proving step or a check. And to do that, I simply draw the box around what either the value or if it's something on the screen that's important. And those proving steps are things that pass or fail your test objective. So now I'm going to go to a query. I'm going to go and get the null accounts. And I'm going to then add a couple of checks in here in terms of status open and unassigned. So these are the values that I'm interested in. So I'm going to get both of those values. So those are two values. You could do it in one check, but I'm going to do it in two checks because I'm going to reuse those later on. And then I'll close Siebel and say stop. So that's how you would create your, and what it has is, as you can see, I have, the action that I'm doing here. If you want to put in descriptive words, you can add descriptive words in if you think it helps. But as you can see, as I go down this, you can see, how easy it is to understand what the test script is actually doing. And that allows you to, as such, it allows you to basically understand the scope and rigor of it. And as you can see, the important steps are these green ones. So these would be your proving steps. So if I have my test objective, these are the steps that I will do to ensure that, the test objective is met. So those are in green, as you can see. And the supporting steps down here, you can see that these are the proving steps. And when I go to a normally supporting step, you can see it's just a supporting step. And I can control, when I get my documented evidence, what I do for each of those step types and also by risk. So that's how I would create my if you like, visual storyboard. Now, so let me save that, and I'll go and get, well, actually I'll open it, and I'll go and get one that's not a visual storyboard. So this is one that's, a traditional, which we still can do, and if people have this, they will simply follow it and attach screenshots as they go. But as you can see, compared to having the actual visual storyboard of what you're doing and understanding what are the important steps in here that you need to focus on to see. It's quite difficult to follow what people are talking about compared to your visual storyboard here. So I've created my test script here in terms of my visual storyboard, and what I can do then is basically I can go and execute that. So let's go and run this. And what I'll do is, and what I'm doing basically is this will go and execute the steps that I have created in my test script, and this runs through your test script steps. We're driving the application here, and we will do the steps and the checks as you go along. And this is, you know, the automation piece working. There's a couple of things to say about it. You know, you need to control where it starts. You need to look at, you know, what it's effectively doing as it goes through. And it fills in, obviously, the details of what you're doing. And it hits all the buttons and it does the checks. So it follows the things. And I suppose the upside is that the tester doesn't have to manually do all the steps and clicks and tests. And if you have a lot of data inputs and stuff like that, obviously that can be the tedious bit of doing it. The downside is that, which I'll show you in a minute, is when I have this test, usually if I run it for this one, so this would be my test script, and I can see now the level of detail that I have for that visual storyboard type script. I picked up the test script number, I picked up, you know, the URS that it relates to, and in the steps themselves, I have, you know, at the proving step level, I have the actual screen that happened when it hit each of those steps. And then for the screen checks of the proving steps, I have the actual piece that I'm looking at. And this is my captured one, and this is when I actually ran it. So this is a real-time view of what happened when I ran it. I don't have to remember to go and get any, you know, I don't have to go and get any screenshots. And here's my other two tests down here in terms of, you know, both of them passing. So that's, you know, it running in automated mode. But let's make it a little bit more interesting now, because how do you then, let's say I wanted to use this for, the other thing to say, sorry, I'll just quickly do it on this one, would be, you know, if I have this documented evidence here that I've just shown you, and I want to actually sign that, you have the ability to electronically sign this in terms of the test script. I hope I've got that right. And this is your unique username and password. Nobody else knows what this is, and you have to sign it in your role. So I'm going to say it as executor, and I'm going to execute that test script. And that signature will then is captured here, and it also will be in the documentation as well, just to show you quickly. So that's your documentation, and at the bottom you will have your details of it electronically stamped as the execution, and also who I am and what I am. And this here won't go in until my user ID and password are correct. So it's just, you can either have that or not have it. So that's my first one. But let's say we're doing it more. So if we open the Knoll account, we can now save this as a different account and actually start changing it and making it more generic so that it can be used for multiple accounts. So let's do that. So to make a copy of it, we simply save a copy of it. And this one we'll call the Envoy account. And add in the test number. So here's our copy of the Envoy. Now I'm going to try and run the Envoy account through this. So let's change the Knoll to Envoy. And when we look at this, there's a couple of things that we would need to do to make this test script more generic. When we're running through this, we're actually using these images to drive the automation. That's how the automation is driven. So when I look at things like this one step here, if I blow it up a bit, you can see that it's going to hit the Knoll no form account there, which is going to be wrong. So what we need to do in those situations is change this to use the labels basically. So if I take the label up to use name, I would use the first record. And similarly, when I go down, I can see that this is SR number is going to change as well from run to run. So again, I need to customize the image. And you may find that it takes 2 or 3 goes to do this. As you go through it, it might get to a certain point and you go, okay, that's wrong. I need to make that more generic. So I've made that more generic now, and this will run through as the Envoy account, and we can automate the Envoy account. So I'll just go and run the test. And again, you will see that we drive through each of the steps and the automation, the UI automation drives that through. It's worth pointing out that the automation goes as fast as is on the screen, so you don't need to worry about whether your Siebel's running. For instance, Siebel's running particularly fast, which it doesn't do in the first run, but does subsequently. So we obviously keep pace with that, and it will go as fast as it goes itself. As you can see there, we're now in the Envoy account, and again, it will go down and it will check the open service request number and check the status and sub-status as it goes along. So we'll just wait for that to finish. And as you can see here, we've actually had a failure. So let's go and investigate what has happened. And you can actually see it down here. So here's our error on step 14. And we have at runtime, we have the substatus is assigned, and obviously the substatus was unassigned for the null account. And if we want to see it in more detail, we can go in here and we can see it as the evidence of what has happened when it has run on that step. And we get down here and you can see this is how easy it is to see what's going on. That this is a screen check. I'm expecting to get unassigned, and when I run through it for that Envoy account, I get assigned and my test fails. So that would be, I couldn't really run Envoy through the same test script as I'd just done for the null account. But is it possible to do both with the same one? So let's go and make a test, show you how to make a test script that will run 2 different accounts, but will look for 2 different values. So how do we do that? So we're going to open this test, and I'll save a copy of this test. And we'll change this now to run with 2 accounts and different values. So we're going to do multiple accounts. 92. So how do we do that? Well, what we need to do is now, is I'll make this bigger here, we need to add in some test data. And I can either, so when I'm adding in the test data, what I need to do is to go and add in some columns here where I'm expecting to put the accounts names, some column headings, and then I'm going to add, for the 2 checks, I'm going to add the 2 check names, so status, and I'm going to add sub-status as well. So this really reads, it's called when then, because what it does is, and I'll just add in null to start with, is when I'm in the null account, I'm expecting to see open and unassigned. So we need to go and put those open and unassigns in there in terms of the expected outputs. So I'll go and get the copy, and I'll just drop it in there. And for this one, I'll go and get the copy and just drop it in there. We then need to add a row for the next one, which would be Envoy. And I can obviously reuse this. Let's make it a wee bit bigger. I can obviously use this status open because that's the same one, so I'll just copy that cell and paste the cell. But for this one here, we've got substatus unassigned, and I need to put in substatus assigned because that's what Envoy is expecting. So I'll go and get that. I can either make it there or I go and get it from another account, another previous made, and this one here has check calls assigned, so I can reuse the checks if they're in any other test script basically. And I'll go and put now paste this in terms of the sign. So the way to read the then when is, so when it's the null account, I'm expecting the status to be open and unassigned. When it is the Envoy account, I'm expecting the status to be open and assigned. So what we can then do is for each of the rows, we will run the automation. And before I do it, I will save it, and I will also, of course, need to add in where it's going to pick up the value. So when it's here, it's going to pick up. I'm going to insert the right value. So I'm going to insert accounts. That'll be your holder, your placeholder for accounts is going to go there. And similarly for the screen check, I'm going to put in my status for the screen check is the status column. And for the substatus, I'm going to put in the substatus. So that's how you would build a generic test. So what we've done is we've built a generic test script, and now what we're doing is we're going to, as it runs through these values, it's going to get to here and it's going to pick up whatever row I select in terms of my null or Envoy. I could actually run them both in a row if I select them both, but let's just run them individually so we can compare them and contrast the results when they come out. So let's go to our run test, and I'm going to select this, and it's going to tell me that we're going to run data row 1. So if I go off and run data row 1, and again it will go through the same process. Click on accounts, go to all accounts, and some people watch this and some people will just let these run and do something else basically. So it goes to the query, and this time it's going to pick up the first one in the run, which is a null account. Drills down on the account itself, goes to service requests, and all this obviously without you having to do anything in terms of clicking and typing once you have set up your data. And that data can be imported or exported as well. And it's just going to close Siebel. So here is my first run of that account, and I'll just go and immediately do the second one. So let's go back to tests, and this time in my test data I'm going to select Envoy, and I will say run, and it's going to run it through in step 2. So this is a generic test script. It is running through each of the different accounts, and it's taking a different value for what it's doing. And that could be working for, if you have order numbers to put in, if you have customer accounts, if you have created an account, if you created an order with different data, you can use obviously test data to make the test script more usable, and you're not just making automation for one type of test script or one set of data running through the test script. So you get more value for the work you do. So here's our 2 test scripts results, and I'll just open them to show you the two different runs in terms of the data going through them. So there's the first one, there's the second one, and when I go down, you can see that this one is obviously, here's your test data here, your null account, and when it does all that, you can see the the actual screens that it captures as it goes along, and here's what actually happened when you did your null account. So my status was unassigned there and unassigned when it was run. And then for the second one, when I ran my envoy, here's where we get to the step where this time what we're doing is we're putting in test data as the envoy account. So it picks up the test data. And here is my assigned this time. So here's your unassigned and here's your assigned. And because you're expecting when names that are different, you obviously have a pass, but it means you can reuse generically the test script and reuse generically the test script with different test sets going through it and different expected results. So different checks or proving steps relating to that account that I've run through it. I would have that level of detail that I've just shown you for all the tests and what has happened to them. So this is your body of evidence of what has actually gone on, and everything is at a step level, whether you've run it in automated mode or in manual mode. And in manual mode, it simply comes up and you type and follow the instructions, but the output is the same thing. We take the screenshots as you're going along, and you decide what level of control you want. So that's kind of a brief and very quick overview of the testing piece in terms of the test automation. I'll maybe just touch on, I've got sort of a couple of minutes left, is you can control what the outputs look like. So I can go here and I can control what's included at a risk level in terms of each of the steps, and I can also then, for each of those templates, I can control. So here's my template I was using. So it has two bits to it. It really has your top and tail piece, if you like. Here's my top and tail piece, and I simply add in what I want it to pick up in terms of the values here of the test script. And then, so that's your top and tail piece, and it's picking up, here's my user requirements. So it picks up your user requirements, your functional requirements, your unique test reference number up here. So it picks it all up, and then you really decide what you want to put in at the test level, at the step level. And that step level is simply, is a document like this where you're actually telling it which values to pick up as you're going along. So the point is you can customize this output that I showed you to your own templates as such. Obviously the history or the execution of what happened are in the tool, but you can output it, customization whatever way you want in terms of doing that output. I can also control who can do what in terms of my users, so I can control what users I have on the system, what they can sign as in terms of their roles, and also I can control who can do what in the restrictions. So if somebody is only a tester and doesn't touch the requirements, I can do that, or they're only allowed to do certain projects. I can control what that is in terms of the projects, and I can also control who does what in terms of workflow. So I can, on a certain event, I can let the next person know that they need to do that. I also have my an audit trail of everything that's gone on, and I can control. I can see what has happened throughout that use of the tool. Okay, so hopefully that has given you a feel, not just at the top level of all the different pieces that I can cover, but also at the test level a little bit more deeper dive into how to create a test and how to use the automation to run those tests, and what you need to do to get the automation to run and make it generic, and also to run data sets through the same test script. Okay, David, have you any comments there?
No, I think other than the fact that you're gonna make me redundant. One of the things I like as somebody who still ends up reviewing a lot of test cases once they've been executed is how ProcedureCapture actually highlights what it is as a reviewer you need to be looking at to determine did that step in the test meet the acceptance criteria or not. I see so many tests that are written and people put in manual screenshots, and you have no idea what you're looking at on the screenshot. So I mean, that plus all the automation and the ability to summarize the status of the testing. I mean, most projects I work at, towards the end of the test cycles, time is always tight, and from a perspective of the validation team supporting the testing, you're always trying to answer the question, are all the requirements covered? Is all the testing complete? And you can just keep an eye on that as it's going through. So it's like the best spreadsheets we've ever developed to track testing, but it's all done for you. So it's great.
Thank you for that. Okay, so if I just go, I have some questions here that people have asked, and maybe we can answer those. So the first one I have is, can we run from the cloud? And let's just see if I can assign that to Mark. Mark, are you there?
Yes, indeed, and you can, guys. You can base your database, your assets in the cloud using. We have it with Amazon Web Services or with Azure, as you see fit. And the underlying database with that is a SQL Server, so it's secure and multi-user. You will connect from your local client through your Azure or AWS portal.
Okay, thanks for that, Mark. Let me see some other ones. Will this work on all my applications and systems? I can answer that. Yes, it will. If it's on the screen, basically, if you can get to it on the screen as well, we execute on a Windows machine, but if you can get to it through anything, any way, an emulator or anything to get to it, we will actually work. So we work on, and we don't worry about the underlying application itself. So we're not, unlike some of the other tools we've written in our past, where we spent our life worrying about what type of application it was, what version it was. Could we see the underlying objects? We don't do any of that. So, basically the rule of thumb is if it's on the screen, we will work. Okay. Let me just see what other ones here. I have one for David. Why are test records not considered subject to 21 CFR Part 11, David?
Yeah, good question. As I said earlier, I mean, originally 15 more years ago, people were considering test records to be within the scope and caused a lot of extra work. But basically, when FDA published the scope and applications guidance with a narrow interpretation, I think that gave most people the confidence to basically say, although the most regulations say you need to validate your applications, the regulations do not list the software test records as something that's subject to GMP, GCP regulation. The only time that might be the case is if you were testing software that's a medical device or part of a medical device, and your test record is considered what's called an inspection record, and I think that's under 21 CFR 820 subpart 70. The rationale for that is in the GAMP testing good practice guide. But the reality is, when you're using a tool like ProcedureCapture, it is secure. You can use electronic signatures, so it's not an issue. But I know for a lot of other tools, the ability to provide that integrity of the test records and to be confident who did what during the testing, even if it's not electronic record, you still need that level of assurance. And you have to work hard on a lot of other tools to achieve that. So unless you're medical devices, don't worry about Part 11, but you do need to worry about security.
Okay, thank you for that. I've got a couple of other ones here. Will there be a video of the presentation available to share? Yes, there will. Here's a good question. When I'm looking at that automation, the question is, what happens if a tester records a test and another tester and another machine wants to run it? Presumably in automation mode you're talking about. will it work basically? And the answer is yes, it will. We are using because we don't use underlying objects. We are using this image here to drive the automation. So things like resolution don't matter. If, however, somebody changed their color depth, let's say, for instance, it actually is a different image. So I think we've seen it once in all the time that we've been running this, where somebody has changed their color depths, and the execution hasn't happened. But obviously, the easy solution was to change the color depths and the person who was using its machine to match the other color depths. So a color depth is actually a different image. Resolution doesn't matter in terms of doing it. Then there's another question here. Is there really no programming required for the automation? No, there's not. So, there's no... In the other tools we've written, there was always an expert view here, and as soon as I clicked on the expert view, I had proprietary code, basically, to run the automation. So, no, there isn't any programming. I will say, we do take, inputs from, when people do automated unit testing, or they do, some developer testing from, for instance, Selenium and stuff like that. If people want to do sort of logical developer testing, we would take the results of it in terms of tracking it against the requirements. But this is very much at a user acceptance testing level, the automation. So hopefully that's answered that. Is it possible to load a test script into ProcedureCapture through a template, or will have to be answered by step by step? You can load it. You can load a test script into ProcedureCapture, and it will come up like the test script that I showed you with all of the descriptions as such, and you would run it in the manual fashion and add the screenshots manually wherever you wanted to. If you want to use the automation and the visual storyboard, or use a visual storyboard for manual execution, then you would need to record it. Okay, I think we're pretty much there. I'd like to say thanks to David in particular, and Mark as well, and thank you for everybody for joining. Our next seminar is, if I back again, our next seminar just is on March the 16th, and I would be looking, well, along with David, at introducing risk and how that affects and I suppose focuses on what you're testing and the way you work. And then the last one really is focusing on agile SDLCs and different types of testing and how session-based testing can be used and those sort of things. So please join them if you can. And I think that's it. David, have you anything, or Mark, have you anything to say finally?
No, just looking forward to the next session.
No,
Okay,
me too. See you guys again.
Cheers, everyone.